Hello, everyone. This is another Mitsubishi Electric podcast. And during the beginning of the year, we tend to have a conversation around various trends in manufacturing industry. And this time, I think I have a perfect guest to discuss this topic with. And I have Tim Dawson from Interact Analysis, who is a Chief Research Officer in this company. So I believe you have a very good overview of how manufacturing looks like today. So I'm very happy to have you here.
Thank you.
Yeah. Maybe you can introduce yourself in a couple of words. I know that in the business of industrial analysis, you are there for a long time.
Yeah, my background, I've been involved in technology market intelligence with a focus on manufacturing for around 25 years now. I'm now Chief Research Officer at Interact Analysis, a company we specialize in market intelligence for technology companies, for manufacturers, focused on industrial automation, robotics and warehouse automation, and commercial vehicle related research. So, automation is a passion of mine. I've been friends with colleagues at Mitsubishi for over 25 years now, and studying the company and the space for a very long time.
So we've benefited from your insights many times, and that's why I thought that it makes sense that we have this discussion for the benefit of our partners, our customers, and so on. So maybe we can start, and the first topic would be about the past. When you're looking at 2025, what do you think were the major trends shaping this manufacturing landscape?
I think there's three core things that I really wanted to talk about today. So there was this global supply chain rebalancing, what we refer to in Interact as the safety first era. So 2025 was defined by this massive reshaping almost of the global manufacturing geography, driven by geopolitics. We've seen this dual movement. So really, I would say Chinese leaders localizing their supply chains to stay compliant and competitive globally. That's one thing, whilst European and US vendors push for more, I would say, domestic resilience. So it's been this complete sort of remapping of the automation world and the vendor supply chain. So that's one thing. I think the second big thing is what we refer to as industrial polarization. So this two-speed economy, as it were, we witnessed this extreme polarization in the market. So while traditional manufacturing sectors really had weak global demand and struggled somewhat, there was this AI arms race almost. So sectors like data centers, semiconductors, and then even sort of humanoid robotics saw this unprecedented investment. This has created really this two-speed economy right now where those tech-driven sectors are sprinting, growing very rapidly and fast, whilst those legacy sectors, some of those more traditional manufacturing sectors, are really undergoing this painful sort of more efficiency-focused consolidation right now, I would say. And then the third big thing really come to the fore this year is the skills gap. So for years, that sort of labour conversation has been focused around aging populations, rising costs of labour. But post-pandemic, we've really hit this much more dangerous wall, in a sense, this structural skills gap and intergenerational talent break, as it were. 2025 was the year where I think that pressure turned into a crisis. This baby boomer generation has been retiring en masse. And when they're leaving their posts, they're obviously taking their knowledge and their expertise with them. So, meanwhile, I'd say that the younger generation, their interest in traditional factory automation and manual roles sort of continues to decline. So that's been a real challenge for end users and customers out there. So to counter that, what we've seen actually is this push towards trying to de-skill in a way the factory floor, making automation easier to use through low-code platforms, through intuitive robotics. really trying to make more complex tasks simpler. We're empowering more general operators to do more rather than things that previously required maybe a specialist engineer. So those sort of things is really what we're seeing on the factory floor more. In addition to that, I think by using AI more to create a knowledge library, we can preserve that soul of the factory, and we expect to see more of that kind of thing in the future. So we're not just replacing human muscles, we're digitizing almost that human experience, so the factory can learn and evolve without sort of being held hostage by that shrinking talent pool, as it were.
Yeah. And I must say that this is definitely something we have seen in with our customer base. So, for instance, there was a huge demand for this kind of visual, flexible programming of robots, as opposed to, the old hard coding.
Yeah.
And definitely, like embedded AI systems have definitely allowed this kind of human knowledge transfer to happen. So we can confirm that many of those things that you're describing were actually impacting our customer base as well. Right. And I think, those trends are not going anywhere. So, for sure, what you just explained will be affecting manufacturing still. However, I think that, this is also a very dynamic industry.
It is.
So we can expect that there is going to be a lot of changes in the coming year, in 2026. So if you have to select the main changes that you are anticipating in manufacturing industry, what is it?
Again, I think there's three big things that I'd like to focus on. So the complexity wall in global operations. So in 2026, that honeymoon period, if you like, of reshoring, going global, we think that will be over. So companies are hitting this complexity wall. It's not just about building like a factory in Warsaw or a factory in Monterey. It's about creating this global R&D and production synchronization that works worldwide. So how do you manage that unified product life cycle across these, now fragmented geopolitical zones? So that's a real challenge. Our research is starting to show that the winners in 2026 will be those that can really master that strategic orchestration, that consolidation and integration, bringing that sort of local market insight with, I guess, global standards. So bringing those two things together is important. So that's one thing. I think the second big thing is what we refer to as pragmatic AI. So the quest for sort of deterministic intelligence. While 2025 had a lot of AI hype, 2026 is really about reliability, I would say, with AI. So in manufacturing, we can't afford AI hallucinations. We see this trend shifting towards niche, high certainty AI applications. It's about solving specific pain points for customers, specific workflow challenges, and bringing precision to those types of things. So for 2026, the focus isn't around can AI do it, but can AI do it safely, profitably every single time and reliably as well. And then I think the third big thing actually is more software defined networking as a new baseline. So this leads us, I think, to more of the ultimate shift of software defined manufacturing. Ultimately, 2026 you'll see the agility of a factory will be defined by its code, and not its physical presence, in a word. So software AI will become much more important. It's the glue that will connect those sort of global R&D features and functions with that local AI execution, if it were. So for technology leaders like Mitsubishi Electric, this really means trying to shift the conversation from individual components and just hardware elements to a more fluid industrial architecture, complete system that could evolve hopefully as fast as the market is right now.
I must say that we are generally a big fans of this kind of reliable AI, mostly because we believe that The way how you can approach AI in manufacturing is actually starting at the bottom with the technology itself. So, for example, it makes total sense to equip the single robot with specific AI features instead of, analyzing all of the robot data somewhere in the cloud. So for sure, this reliable and edge level AI is something that we are strongly promoting. And then the adoption of industrial automation is accelerating across different industries for sure. So you see advanced automation systems in food and beverage, automotive, and even places like, data centers these days. So basing on your experience and the research you have done so far, which market segments will experience the highest growth in the coming year?
I mean, there's a few, I'd say, critical industries, core industries that I mentioned already, and a few that are additional ones that are performing really quite well right now. So I'd say semiconductor and electronics components and that industry is really expected to maintain this very strong momentum into 2026, especially driven obviously by the AI boom, the shift towards digitalization and smart manufacturing is increasing within demand for electronic components and the need for semiconductors more broadly. So based on our manufacturing industry output tracker, which really measures the value of manufacturing output by country, by industry, for 102 industries, for 45 countries worldwide, we actually expect the global semiconductor and components industry to grow by about 7% in 2026. This significantly outpaces, I would say, the sort of 3% growth that we anticipate for manufacturing as a whole globally. So big difference there in growth. Other key sectors growing quite nicely right now, the transportation equipment industry. So globally, shipbuilding is remaining in like a boom cycle right now. Aerospace, we expect to gain, I'd say, more momentum in 2026, supported by, I'd say, rising defense spending across multiple regions. And then the warehouse and logistics sectors really are projected to continue to grow faster than manufacturing. So it's been that way for a while now, for a few years. We expect that to continue in 2026. Steady adoption of automation equipment being used in, things like mobile robotics, more automated storage and retrieval systems, palletizing robots, just automating logistics and that's sort of coming off the demand for increasing e-commerce globally. So those key things helping to drive above average growth. And then finally, I think when you think about manufacturing for the last few years, 2023 to 2025, it's had like a fairly subdued time. It's been a tough environment out there for many. We do hope and expect to see a little bit of a resurgence and some positive signs of growth across manufacturing more broadly in 2026 as well. But not hotspots, but yeah, brighter spots than we've had certainly for the last few years.
Let's hope for that because, as you said, like 2025 was tough on manufacturing companies across Europe. Let me ask you follow up on that. When it comes to semiconductor industry, do you believe that this is something that can grow in Europe as well? I mean, we don't have the same experiences, for example, Asia. But on the other hand, Europe has also a strong potential. So what is your expectation towards semiconductor business?
I think it definitely represents an opportunity within Europe still. It's obviously a more a smaller opportunity overall compared to Asia, but there are pockets of activity within the region. I think it will help to drive demand for automation equipment. If you are able to sell your products to semiconductor end users and end equipment users and ultimately the machinery companies that are making semiconductor manufacturing equipment as well, then yes, there's definitely an opportunity there.
You already mentioned the pragmatic AI or reliable AI approach. And as I said, AI has been a very important technology that affected the manufacturing industry already. And we definitely expect this is not going to change in the coming year. But if we could go into details, so how do you believe the AI will shape the manufacturing from now on?
So I think in 2026, AI will obviously remain a dominant technology in manufacturing, not as a standalone trend, but really as a foundational layer, accelerating, I would say, complementary innovation in a way. So AI's position will be solidified as that foundational technology of modern manufacturing, not through hype, but through more measurable, scalable value creation. So moving beyond experimentation to become a more competitive necessity for companies, for end users across hopefully all manufacturing segments. So I think there's 4 key things that we'll start to see increasing over time. So increasing deployment scope. So what we're seeing is this transition from AI being trialed in pilot applications. So moving from that to a shift to more systematic implementations across a broader segment of a manufacturing line or production process ultimately. So that is one key thing. But with that, I think trying to integrate different aspects of the manufacturing line as well. So be that R&D, manufacturing itself, operations and other layers of integration more broadly. So that's one aspect. I think improving data norms and sort of governance will help to create standards for AI. So large model training and AI deployments are obviously data driven. In 2026, more refined AI norms and standards are really expected to be established. That should really help to ease the deployment of and increase the use of AI more broadly, I would say, in manufacturing especially. And then I think the enhancement of AI, both digitally and physically. So AI's capabilities are expected to expand beyond that sort of semantic level analysis and output. It will develop higher level capabilities. So better reasoning, better planning, motion control, potentially refined sort of physical capabilities. And we're seeing that with robotics. And ultimately, it would be nice to get to improved autonomy in factories ultimately. So self-correction and minimized human intervention over time. So there's definitely more we can expect and anticipate there. On the energy front, we're seeing AI used as well for energy management to support an industry's low carbon development as well. So those things as well. And then finally, I think the big thing, infrastructure improvement. So that you mentioned it already, edge computing. I think that will help to drive AI computing's architecture and the shift from more of a cloud-centric to a distributed model in a sense. So particularly in manufacturing applications, that edge AI will help to reduce latency, improve processing speed, and just ease that process along. So there won't be a shift away from AI in 2026. It will be about adding additional features, functionality, synergy and integration with emerging technologies such as digital twins, such as edge computing, will propel us, I think, to greater autonomy more broadly. I think manufacturers that are able to treat AI as this core operational system rather than experimental tool will be the ones that do this most successfully and then ultimately capture this competitive advantage potentially. So what I think we'll see is AI transitioning from this nice to have position to more of an existential necessity in a way. So increasingly that automated and data-driven global manufacturing landscape is, that will become more and more important. So,
and I must say that, with the edge level AI, this is definitely the bet we are making, right? So, we strongly predict as well that, this kind of localized edge, analytics will become key to the future in manufacturing due to the latency, as you mentioned, but not only, right? But this is our expectation that, and this is a type of, approach we are taking to keep the AI solutions as close to the equipment as possible. And this kind of self-improvement of, for example, robot positioning, this is something we already deploy here and there. So there are applications where the robot is constantly learning how to position the elements better. So those type of applications already happen, and we see them in real applications across industries. In my recent discussion with Oliver Geertz from our company, we have discussed the topic of predictive maintenance. So in more complex machinery, where you have a lot of either servo axes or robot arms, the maintenance of such system is always a costly endeavor. Mm-hmm. And we discussed that predictive analytics, predictive maintenance allows for a huge savings. And definitely that's why this is a huge topic for many manufacturers. So what do you think about the future of predictive maintenance? How do you see it developing in 2026?
I think, 2026 will be the year of closed loop AI in manufacturing. So it's really not, it's no longer good enough for AI just to raise an alarm. Like a true closed loop system in that sort of sense means three things. So with AI, it's identifying, I would say, the anomaly, and doing that with the proper precision. It's then AI evaluating and assessing that business risk, linking it to the production schedule potentially, deciding, is it an appropriate time to stop the system and fix right now, or, shall we wait? So it's more based on understanding like the ROI impact on, preventing or holding back on your maintenance at a point in time. So not just the physics of when it's a problem. And then I'd say AI guiding, that closed loop, system as well. So when it acts as really as a digital mentor, providing step-by-step, potentially repair instructions to the engineer or the technician on the floor, helping them to, resolve the problem. So it's more of a transition from diagnostic AI and just having, the ability to understand that there's a problem to more operational AI and a closed loop system where, we're almost starting to solve that labor skill gap problem, whilst minimizing, downtime in the system.
Yeah, I was going to mention the labor shortage topic because it is a huge problem, as you said before. And, like many companies are searching for like traditional ways to solve it. I mean, finding a way to automate more processes and so on. Mm-hmm. But for instance, what you just described is a perfect example how to address this labor shortage, right? So you get the insights from AI. So the process of maintaining and repairing the equipment is faster. And then, this knowledge stays in the system, right? So there is some rules, some insights in the system which allow operators to solve the issues, right? So I think that's a very, very important point for the future of maintenance, and also on top of that, how to address the labor shortage problem in the long run. All right. So we touched on many points, and I think that what we should also try to do is to give a sort of guidance how to move forward. So what would you suggest the manufacturers should prepare for in the coming year?
Good question. So I think, again, three core things critically on that side of things: bridging that IT and the OT gap today. So AI can't help you to close that loop and see the business impact, and if it can't see that business impact. So manufacturers need to really start integrating their machine data, that OT data, with their maintenance logs, with their ERP systems at the IT level as well. So you need to know the financial cost of a vibration, and not just the frequency of it, for example. So that's one aspect. I think a second aspect is really digitizing more broadly your knowledge of your machinery, of your equipment. So start capturing that how-to knowledge of your veteran engineers now. Voice memos, video snippets, detailed repair notes. Those are the sort of things that act as training data for AI co-pilots in 2026. So if it's not in the system, AI can't teach it for the next generation. So that could become a barrier for you. And then I think focusing on really the best ROI opportunities. So identify your single biggest points of failure, your real workflow challenges, and start there. The winner in 2026 won't necessarily be the factory with the most amount of sensors, but the one that really successfully closes that loop most effectively on those most critical sort of bottlenecks in production.
So I did expect that we will spend a lot of time today discussing AI. Obviously, it's a technology that probably has the biggest impact on various industries, but definitely manufacturing. And I thought that maybe we can discuss one more point, which is the Agentic AI. So there is a lot of discussion around this. There are some, developments in Agentic AI in, let's say, more traditional general AI applications. How do you see that happening in manufacturing industry?
I guess we see it coming through as more a concept of this cognitive industry with industrial AI agents gaining momentum more broadly. So there's a couple of things we see. I'd say on the software side, AI enabling easier operation and control of facilities and setting up equipment. So examples might include using natural language programming for PLC coding or for setting up vision systems, AI assisted engineering works generally for the sort of integration side of things, obviously in condition monitoring and predictive maintenance of machines, as we've mentioned before, and components within machines. Those things all combine together really to help reduce the technical expertise required from operators. And it starts then really to address the labour shortages, the skills gap challenges that we were talking about earlier, and improving accessibility, I would say. It gives an opportunity for more companies to adopt more automation more broadly. So that's kind of on the hardware side. On the software side, obviously improves motion control and the level of automation that could exist more broadly, allows for more autonomy more broadly. So optimized path planning of robots is definitely something that AI and agents are supporting right now, adapting to more complex working environments and bringing flexibility there. And then I think finally really AI-powered machine vision being used for robot guidance. So again, improving the level of automation, increasing throughput potentially and reliability of systems, and really reducing either sort of false defects or errors in production. Again, those things all coming together with this cognitive industry and manufacturing line.
Okay, so Thank you, Tim. And I must say that this discussion was extremely practical. I mean, you gave us not only like general trends and insights that we could expect from an analytical company, but you actually you do understand the manufacturing technology very well. And I think that you gave a couple of very, very important examples of how, for instance, AI could be utilized in specific applications. So I'm very grateful for this conversation. We will stop here with the part 1, actually, because I think that there are many, many more things that we can discuss. So stay tuned for another part of this discussion with Tim. And we already invite you to that event close in the future. So, Tim, thank you very much.
Thank you for having me. Appreciate it.